So coming to step 2 of our standard process, that is knowing the frame of reference. To better understand frame of reference, first of all, we should understand what actually physics is. Physics is the systematic and scientific study of any natural phenomena. Since earlier times, human beings were highly fascinated by the natural phenomenon of sun always rising in the east and setting in the west. And during the course of the time, with change in the position of the sun, the day changes to night and again to day. So human beings wanted to predict the time at the particular position of the sun. So this curiosity has led to some steps or led to a process that we still study today, that is the scientific method, where we do in-depth observation of any natural phenomena. Based on that observation, we do controlled experiment, and based on the experimental data that we have, we do qualitative and quantitative analysis. Based on that, we do mathematical modeling and then the prediction and verification of the model. So to take a simple and hypothetical example, we'll consider a mouse and cheese. So in this hypothetical example, where we have mouse and cheese. So by observation, or you can say in our everyday life, we see that mouse is always attracted toward the cheese. So based on that observation, we have conducted this experiment, and we know that okay, mouse is always attracted toward the cheese, and this is the repetitive behavior that is shown by the mouse towards the cheese, just as the case of sun always rising in the east and setting in the west. So what we did after the observation, we wanted to predict the movement of the mouse. We did a controlled experiment in a laboratory setup where we have a mouse that is kept at the edge of the wall, and we have a cheese. And to conduct the experiment, we initially kept the mouse stationary at the, you can say, the edge of the wall, and we vary the distance of the cheese from the mouse, and we'll note the time during which is taken by the mouse to reach the cheese. So we kept the cheese at a distance of 1 meter from the mouse, and we released the mouse, and we noted the time when the mouse reaches the cheese. We found that it covers the distance of 1 meter in 2 seconds. We again increased the distance of the cheese to 2 meters and released the mouse from the edge of the wall, and we noted the time to be 4 seconds. Again, we increased the distance of the cheese to 3 meters and released the mouse, and we found that the mouse reaches the cheese in 6 seconds. So after the controlled experiment, we have some data, and after doing the qualitative and quantitative analysis, we found that the distance traveled by the mouse is directly proportional to the time. Here we can see that it covers a distance of 1 meter in 2 seconds, 2 in 4, 3 into 6. So we see that there is some relation between the distance traveled and the time taken. And we, after doing the analysis, qualitative analysis, we found that it is the distance traveled by the mouse is directly proportional to time. So to convert this into an equation, we have to apply a constant c. We'll use any data point and we'll find the constant c. So c will be d by t. Here d is the distance traveled by the mouse, and t is the time taken by the mouse to reach the cheese. we take a data point of this data point where the distance traveled is 2 and the time taken is 4. So this is 0.5, and we can, as we see from this equation, the unit is meter per second. So this is the mathematical model that we have here, and now we need to verify this model. So how do we verify this model? We again continue this experiment and increase the distance of the cheese to an unknown distance. Suppose this is the distance, that is x. We kept the cheese at an unknown distance which we haven't measured, and we just release the mouse from this edge of the wall and noted the time when it reaches the cheese. So we found that the time is, suppose, 10 seconds. What we did, we placed this 10 second in this equation, that is d is equal to c into t, and we know this constant to be 0.5. Time is 10 seconds, so we found out that the distance is 5 meters. And now what we did, we actually measured the distance, and we found that this distance is exactly 5 meters. So our model gets verified, and now this, once it is verified, we can use this model to